Hi, I'm Joanna Schroeder, and I'll be presenting the research exploring veteran career pathways in Virginia, Maryland, and DC using sequence analysis. The other members of the team for this project are Josh Goldstein, Aritra Halder, and Sally Keller, and we're from the Social and Decision Analytics Division of the Biocomplexity Institute at the University of Virginia. And our research project was sponsored by the U.S. Army Research Institute for the Behavioral and Social Sciences. So I'll start with an overview of our broader research project with ARI. So for this research, we are hoping to develop predictive models of U.S. Army career pathways using existing Army administrative and survey data, as well as other non-DoD data sources. This is accomplished by leveraging expertise developed within the Person Data Environment, or the PDE, which is an Army data enclave, and developing a longitudinal characterization of a soldier's knowledge, skills, and abilities acquisition through incorporation of individual and contextual information. Our graphic here is outlining the major steps in this research process. So the research I'll be presenting today is really concerned with the first step in the process, testing research questions and models on data external to the PDE, and the subsequent steps in this process move from exercising the SDAD data science framework to developing career profiles and modeling career pathways of officers in the PDE to refining those models and extending the research to enlistees. So our overall research problem is concerned with the Army's capability to manage talent over a soldier's career pathway. Moving into the specific research I'll be sharing today, we're approaching this problem by identifying veterans in the resume data from Burning Glass Technologies and linking this data to information from the Occupational Information Network to construct a typology of career pathways using sequence and cluster analyses. So like I mentioned earlier, we're in the initial step of this research process, which is testing research questions and models on data external to the PDE. Specifically, we're exploring veteran career progression in the first 10 years after leaving the military for veterans from Washington, D.C., Maryland, and Virginia, and later Texas. The Washington, D.C., Maryland, and Virginia region was chosen as a proof of concept for this research because of the large number of employed veterans in the area, and Texas was chosen as sort of a point of comparison to represent a population demographically different than veterans in the DMV. Now I'll go into a little more detail about the data sources we're using for this project. To begin, we're using data from the Occupational Information Network, or ONET, specifically job zones. ONET is a program sponsored by the Department of Labor that maintains a database of about 1,000 occupations. Each of these occupations is classified manually by a trained analyst into one of 5 job zones based on the education, experience, and training necessary for the occupation. So job zone 1 being the least preparation necessary and job zone 5 being the most preparation necessary. We're using job zones in this analysis as a way to compare career progression across industries and get a sense of career mobility, or how individuals are moving from job zone to job zone over time. Next, I'll talk about the resume data. The resume data used in this analysis is produced by Burning Glass Technologies, or BGT. This is a proprietary data set of over 78 million unique resumes. So this data set contains information scraped from resumes posted on recruitment and workforce agency websites and job boards. The resume data contains over 50 variables. Some of the specific variables used for this analysis are the occupation start and end dates in the ONET occupation codes, as well as job seeker skills and locations. For this analysis, we identified veterans by identifying individuals with a military ONET occupation code in their job history. To obtain a comparative example of non-veterans, we took a random sample of the non-veteran population from DC, Maryland, and Virginia, and we stratified this population by gender, zip code, highest degree earned, and date entered the workforce. Now I'll go into a little more detail about the methods we used for this project, which were sequence analysis and clustering. So for our project, we defined career progression using individual resumes, and this is captured by the transitions between employment, unemployment, and education, beginning with the first job on the resume. These transitions are described using sequence analysis, which is a type of longitudinal analysis where linear data is defined as an entire sequence. And these sequences are comprised of states, which in our case are job zones 1 through 5, education, and unemployment. Each sequence is 10 years in length, and sequences are standardized to begin upon military exit. So it's the first 10 years after exiting the military for these veterans. And then to develop a typology of careers, our sequences are grouped by similar characteristics using cluster analysis. So the clustering process involves choosing a dissimilarity metric, a method of clustering, and a number of clusters. Our approach for tuning for these different clustering parameters combines searching for the optimal cluster solution based on a criteria or several criteria of cluster quality and our substantive ability to interpret the clusters in the context of our analysis. We cluster these sequences to develop a typology of career trajectories, which basically translates to resumes with a similar pattern of job zones, education, and unemployment over time. So here's a more detailed example of our process of data linkage, where we're transforming raw resume data into a career sequence for cluster analysis. So on the left, we have a few variables of resume data for an individual, and we can tell this individual is a veteran because they have a job in their career history with an ONET occupation code beginning with 55. So the main takeaways from this process is we're converting these ONET occupation codes and connecting them to ONET job zones to be able to compare career trajectories across industries. And we're taking information from the education table of the Burning Glass data to impute the periods of time an individual was in a state of education. So this is moving from the left to the right. And then from there, we subset the career history to only include positions in the first 10 years after military exit. So we can see this individual ends their military position in 2005. So we're only looking at jobs where employment begins after 2005. Because sequences are made up of states, we can only choose one job state for an individual in a given year. So we choose to assign the highest job zone or education as the state for that given year. And after all these transformations, this yields a sequence that goes from zone 4 to education to zone 4 at the bottom here. As previously mentioned, part of the goal of this research is to develop a longitudinal characterization of a soldier's knowledge, skills, and abilities acquisition. The BGT data is pretty useful to explore initial modeling efforts for skills acquisition because the resume data includes information on reported skills. So this slide describes the Burning Glass skills taxonomy. Skills are categorized at 3 levels. Skill being the most basic, and then skill clusters going up 1 level, which are groupings of similar skills, and then skill cluster families, which map roughly to career areas. So the graphic here gives an example of skill clusters and skills within the skill cluster family for information technology. So here we're looking at the most frequent skill cluster family per resume by the % of veterans in each job zone. Specifically, this graphic is ordered by percentage of veterans who reach a zone 5 job in their career, the most frequent at the top and the least frequent at the bottom. So at the top, we have economics and policy and social studies. So of the 51 veterans whose most frequent skill cluster family is economics, policy, and social studies, 28 or nearly 55% of them reach job zone 5. The economics, policy, and social studies skill cluster family includes the skills such as policy analysis, economic modeling, and urban planning. So this gives us an indication of what kind of skill sets we might see represented by the veterans who occupy these higher job zone clusters when we get to the stage of clustering our resume sequences. Now I'll go into a little more detail about our process for refining sequence analysis and clustering. As I mentioned earlier, we went through a process of choosing our parameters for sequence analysis and clustering, including the sequence dissimilarity metric, cluster method, and number of clusters. We evaluated different combinations of cluster parameters on 4 measures of cluster quality. The figures here compare the cluster performance for 3 dissimilarity options and different numbers of clusters according to 2 measures of cluster quality, average silhouette width, and R squared. The high-performing parameter combinations are indicated by the yellow, green, and yellow areas. So to choose our parameters for sequence analysis, we combine this step with the substantive interpretation of the produced clusters to the context of our research questions about career trajectories. Now I'll present some of our findings, starting with our finding of veterans in higher job zone clusters. Here we have a figure that shows our clusters on the left and the breakdown of our variable distribution overall and in each cluster on the right. And the clusters are grouped to analyze for higher level patterns in career trajectories. So we have clusters featuring education, promotion, overall no change, demotion, or unemployment. So we found that clusters featuring zone 5 jobs had a higher percentage of veterans compared with the sample overall. For example, while 60% of the sample overall were made up of veterans, nearly 70% of individuals in the zone 4 to zone 5 promotion cluster were veterans. Because we're starting the career sequences for veterans at their first civilian position, the results here factor in comparable years of experience for non-veterans. So this pattern of veterans in higher job zone clusters was observed to an even greater extent when not factoring in years of experience for non-veterans. In addition to our analysis in DC, Maryland, and Virginia, we replicated our analysis in Texas. Our goal here was to test the external validity of our sequence cluster tuning process and to see if patterns of covariate distribution in the clusters held up in a new region. So our sample size of veterans in Texas was slightly smaller and also represented a slightly different demographic population, being made up of less advanced degree earners and less military officers than DC, Maryland, and Virginia, and also including a more rural population. So here we're looking at the distribution of officers in the combined tenure clusters. So this includes both Texas and DC, Maryland, and Virginia veterans. On the left, we have the clusters again visually represented through the representative sequences. And on the right, we have the breakdown of officers in each cluster and overall. So here we find that a higher percentage of officers consistently make up clusters featuring zone 5. Interestingly, a lower percent of officers are observed in the zone 4 to unemployment cluster, but then are more evenly distributed in the zone 4 to unemployment to zone 4 cluster. And this indicates that maybe officers are more able to bounce back from a period of unemployment compared to enlisted. Finally, we have the results for the distribution of the skill cluster families in the combined DC, Maryland, and Virginia and Texas clusters. So the clusters here are on the horizontal axis and the skill cluster families are on the vertical axis, ordered by decreasing sample size. So the largest sample size is at the top. These results are interesting to look at by observing the patterns in the larger groups, the larger cluster groups. So for example, individuals highly skilled in maintenance, repair, and installation are consistently underrepresented in these education clusters here, while individuals skilled in analysis are consistently showing up at a higher frequency in these education clusters. And thinking back to our earlier slide in the presentation, we do see that individuals skilled in economics, policy, and social studies, as well as science and research, appear more often in clusters featuring Zone 4 and Zone 5. So to wrap up some conclusions from our research, overall, we found that types of career trajectory clusters, this is the education, promotion, these broader categorizations of clusters, were not as influential as the individual job zones that made up the career clusters. So for example, officers were more likely to be in a cluster containing Zone 5, regardless if it was an education, promotion, no change, demotion, or unemployment cluster. We found that individuals earning a master's, PhD, and officers were more frequently observed in these clusters featuring Zone 4 and Zone 5 jobs. Similarly, individuals skilled in economics, policy, and social studies, science and research, and analysis were also consistently observed in clusters containing Zone 4 and Zone 5. Finally, individuals majoring in computer science were less likely to be in the unemployment cluster. Thank you for listening to the presentation. If you're interested in learning more about this research, please check out the presentation on spatiotemporal modeling of career pathways by Aritra Halder, who's also from the Social and Decision Analytics Division of the UVA Biocomplexity Institute.